You are listening to the Vocal Technologist. Spoken tech for your ears.
If you're in cloud engineering, you definitely know the feeling.
Yeah.
You close your laptop on a Friday, you feel like you're on top of things.
Right.
And then by Monday morning, half your favorite frameworks are gone. Kubernetes has, 60 new features. And there's some AI agent trying to rewrite your entire pipeline.
Exactly. The velocity is just staggering right now. And that's really why we dug into the latest data, the roadmaps, security reports, all of it, to give you a real shortcut to what matters for 2026.
And you found some major themes, right?
We found three massive, I'd say, tectonic shifts. First, there's this push toward extreme infrastructure scaling. It's pushing Kubernetes and, frankly, the cloud providers themselves to their absolute limits.
Again, the second one, this one feels more personal. It's about the engineer's role itself changing.
It is. It's no longer just about, shipping code. It's now about validation, governance, accountability, all in this incredibly complex new world.
And the third theme?
Well, the one that's driving everything else, really. It's the inevitable integration of AI agents. I mean, they're not just tools anymore. They're becoming what you'd call first-class platform citizens.
Wow. And that forces us to rethink what a safe deployment even looks like.
Completely.
Okay, let's unpack all of this.
Yeah.
I think we have to start at the foundation with the infrastructure itself. I mean, Kubernetes and the IAC layer feel like the right place to begin.
Yeah, we have to start with Kubernetes v1.35. They've even nicknamed it Timbernetes, the world tree release.
Oh, like that.
But the sheer breadth of the update is the real story. It has 60 enhancements hitting the street.
60.
60. 17 of those are stable, 19 are in beta, and then another 22 are in alpha. It's just a huge, powerful, and frankly demanding release.
I did see 2 general availability updates in there that sound, absolutely massive for stability.
Yeah.
And that's what platform teams really care about with K8s at scale.
Oh, they are mission critical. The first one is that in-place updates for pod resources is now GA.
Okay, break that down. Why is that such a big deal?
Well, for anyone running K8s at scale, it's a huge quality of life improvement. Before, if you wanted to change a resource limit, say, give a container more memory, you had to do a full pod restart.
Which always risks some kind of momentary service disruption, a little blip.
Exactly. So now you can just adjust those boundaries on the fly without that heavy-handed interruption. It's a massive win for efficiency.
Okay, and what about the other major GA feature?
That would be the native workload identity graduating to GA with automated certificate rotation.
Ah, that solves so much operational pain.
It really does. Think about it. You no longer have to manually juggle short-lived secrets or some external process for rotating keys. K8s is basically giving itself a built-in self-managing key system.
Which boosts security and just cuts down on all that tedious rotation work.
Right. But, like you said, K8s is demanding. It gives with one hand.
And it takes away with the other. I saw some major subtractions here that are going to create some, non-negotiable tech debt for some teams, immediately.
Absolutely. The removal of cgroup v1 support is a big one for anyone on older distros. And they also deprecated IPVs mode in kubeproxy. But the loudest alarm bell...
Let me guess. The NGINX ingress controller.
That's the one. The announcement that it's being retired.
Wow. That's the workhorse for tens of thousands of orgs. This isn't just an inconvenience. This is a forced strategic shift. They're pushing everyone to the Gateway API, right?
Right. K8s is making it crystal clear. If you want all these new stability and scaling features, you have to modernize your entire stack with it. It's a forced march to the future.
And that march toward scale isn't just in the orchestration layer, is it?
Yeah.
The cloud providers are all in. Look at Azure. They're just doubling down on sheer physical scale.
AI-optimized data center fabrics, new region expansions.
Yeah, they're literally building a new region, East US 3, down in the Atlanta area.
Yeah.
It's wild. The complexity is becoming geographical.
And what's fascinating is how that scale, that physical scale, immediately creates instability in our tools in the control plane, which brings us right to the shakeup in the ISC landscape.
Right. When the foundation changes that fast, the tools you use to manage it, they just break.
They do.
And the biggest break right now has to be the official deprecation of CDK for Terraform, CDKTF, December 10th, 2025.
That date is coming up fast for teams that really bet on using, TypeScript or Python to manage their infra.
So what's the migration path? Is there a clear one?
There is, even if it's a bit politically awkward. The consensus is pointing squarely at Pulumi as the simplest replacement.
Pulumi.
Yeah, it offers that same multi-language support that CDKTF users loved, and critically, they have built-in conversion tools designed specifically to help projects move over smoothly.
Wait, I have to stop you there. So HashiCorp, the company that created Terraform, is deprecating this major tool. And the widely accepted migration path leads directly to Pulumi, one of their main competitors. I mean, how did that happen? That seems awkward.
It is, and it says a lot about the state of the tooling world. HashiCorp's own 2025 review admitted that all this new complexity is coming from multi-cloud sprawl, security, and AI.
So they're changing focus.
Exactly. They're focusing less on the developer abstraction layer, which is what CDKTF was, and more on doubling down on lifecycle automation and embedding security directly into their core products. You know, Terraform, Vault, HCP.
So they're focusing on governing the infrastructure state, not so much the language you use to build it.
Precisely. They know the old IAC model can't keep up with the velocity, so they're trying to automate the management and the security of that complexity instead.
That makes a lot of sense. And speaking of AI and complexity, let's look at how the AI agent is just fundamentally redefining everything, our code and even our jobs.
The data here is it's unambiguous. The prediction for 2026 is that platform engineering is no longer a competitive advantage. It is the minimum price of entry.
Just to stay operational.
Just to stay in the game. And AI is the engine driving that requirement.
How so? It can't just be about generating boilerplate code faster.
No, it's so much deeper. AI agents are becoming, as we said, first-class platform citizens. They're not just suggestion boxes anymore. They are orchestrating whole subsystems. They're initiating changes based on metrics they observe.
And they're drafting the infrastructure code themselves. So that raises the big question, who reviews it?
Exactly. That is the key shift. You can't just drop an AI-generated pull request on a human developer's desk and say, hey, can you validate these 500 lines of Terraform before lunch?
No, it's not feasible.
Which is why the platform itself is now expected to be the primary reviewer for AI-generated code. The platform, with all those embedded policies we talked about, has to be the first line of defense.
That's a huge change. We actually saw a great, tangible example of this in action from Dropbox Dash. They built a custom feature store to power their real-time AI search.
Oh, the architecture they built for that is just brilliant. It's a hybrid design. They use standard tools like Feast for orchestration and Spark for the heavy computation.
But the secret sauce is their own thing, right?
Right. It's their in-house component called Dynavault. That's what handles the incredibly low latency lookups they need for future retrieval.
And the performance numbers are just stunning.
They really are. They're getting sub 100 millisecond P95 latencies for thousands of feature lookups in a single query. That kind of speed, it's not aspirational anymore. It's quickly becoming the baseline.
And it's not just application data. We're also seeing these specialized AI ETL platforms pop up.
Yeah, they're automating entire data pipelines. They use machine learning to dynamically map schemas, transform data, even detect quality issues on the fly.
Which is something traditional ETL has always struggled with, right? Unstructured data, schema drift.
A nightmare. AI ETL platforms basically overcome that by understanding the context of the data and just adapting. It takes all the guesswork out of data integration.
Okay, all this automation sounds great, but it immediately creates huge accountability gaps.
Yeah.
I mean, who's responsible when the AI pipeline violates compliance? And that's why I was so fascinated to see this new emerging role that seems designed to fix this. The governance, risk, and compliance engineer. The GRC engineer.
The GRC engineer is basically the adult supervision that DevOps finally realized it desperately needed.
Huh. I think you're right.
You know, historically, DevOps often prioritized speed over strict governance. And the GRC engineer's job is to embed policy, compliance, and telemetry directly into the CI/CD workflows from day one.
So they're using tools like Azure Policy or GitHub Enforcement to make governance a core engineering task, not some painful review that happens once a quarter.
Exactly. They make sure automation doesn't sideline policy. If an AI agent writes the code, the GRC engineer makes sure the platform has the gates to review it. Compliance becomes proactive, not reactive.
And that need for immediate enforcement is so critical when you look at the security landscape. I mean, the threat environment is white hot.
It is.
I saw a really nasty recent one. The React 2 shell vulnerability. It's a critical 10.0 CVSS score. A remote code execution flaw in React server components.
A critical RCE is always bad news. But this one was particularly troubling because of where it is. React server components run on the server, often in these high-trust environments.
And it lets malicious input execute code on the back end.
Right. It's a very serious breach of trust in a really foundational part of the framework.
And the speed of exploitation was terrifying.
Yeah.
I mean, widespread scanning started immediately after it was disclosed, mostly from Asian nexus groups. The window between disclosure and attack is just gone.
It's gone. It required an emergency defensive response. And thankfully, those defenses paid off. I mean, Cloudflare alone deployed WAF rules that blocked over 582 million related attacks.
582 million. That volume is just staggering.
It shows the scale of the coordinated attacks we're up against now.
It really underscores that this high-stakes world demands flawless delivery. And that brings us to our last area, the new metrics of engineering and what success actually looks like. And for those of you listening to the Vocal Technologist, this is really the heart of what we mean by technical accountability.
Let's start with the mobile CI/CD data because it shows this classic contradiction. Build times fell by 28%.
So we're building faster.
Much faster. But at the same time, workflow complexity rose by 23%. So you're faster, but you're managing exponentially more moving parts.
That sounds like a recipe for total burnout, but the data seems to suggest teams are actually handling it.
They are. You see that complexity in the shift to multi-workflow pipelines. That surged from just 16% of all builds to 42%. And the research also proved what we all kind of knew. Teams with structured release frameworks ship code twice as often.
They're finding order in the chaos.
They are.
The thing that really caught my eye, though, was the adoption gap, the difference between the fastest teams and everyone else.
Oh, that's the competitive killer. The fastest teams adopt new dependencies, like a new Xcode version, in under 4 weeks. Most teams take 19 weeks or more.
19 weeks. So you're lagging by 5 months on critical tooling.
Right. And that means you're already losing out on security patches, performance benefits, everything. It creates massive pressure.
And that need to be both fast and correct is driving what people are calling the observability mandate. I saw that for 2026, 60% of organizations are expected to reach mature or expert levels of observability.
And that maturity is key, but you also have to understand the different methods. Whole system observability, basic metrics, sampling. It's cheap, it's good for capacity planning. It's like the dashboard in your car.
It tells you fuel and oil levels, but not why the engine is knocking.
Exactly. It fails to explain what's happening inside an operation, and that's where per-process tracing comes in. It provides the exact timelines you need to find the highest ROI optimizations.
It's like the mechanic hooking up sensors to find out exactly which cylinder is misfiring.
Precisely. It tells you not just that something is slow, but why it's slow at a micro level.
But how do they do that efficiently? Isn't tracing famously resource intensive?
They do it smartly now. They often use techniques like early exit syscall paths. So in simple terms, the system is just checking for relevant data right at the kernel's entrance or exit, not running the whole process to see what happened. It dramatically reduces the overhead.
Ultimately, all of this, the metrics, the security threats, the scale, it all leads back to this core philosophy about the engineer's job.
Right.
Your job is to deliver code that is proven to work.
And that accountability cannot be shifted, not even when AI coding agents are involved. You can't just dump a huge AI-generated change on a reviewer and make it their problem.
The human engineer is still accountable for the evidence.
The proof. The proof. It still requires manual testing and automated tests. That responsibility stays with the person hitting merge.
Well, the good news is the toolings is getting better at supporting that. I mean, GitHub rebuilt the core of actions to scale to 71 million jobs a day. They added YAML, anchors, reusable workflows, bigger caches.
The friction is being removed so you can focus on the hard part.
Which is the validation.
Right.
Absolutely. So what an exploration. We've seen K8's scaling force modernization, the death of CDKTF, the rise of the AI agent as a platform peer, and this renewed focus on engineer accountability.
I think the key insight for you, for everyone listening, is that even as automation takes over more and more, the human role is shifting. It's moving away from just building things and toward compliance and validation. We are becoming the safety guardians.
That's a great way to put it. We're the guardians of correctness. It's a fascinating and very fast evolution, which leaves me with a final thought for you to mull over.
Okay.
If the industry is really moving to a world where AI agents orchestrate subsystems and platforms review their code, what will be the single non-negotiable definition of proven to work when the line between human and machine authorship just disappears?
Spoken Tech for your ears.